In this video tutorial, we'll cover how to set up and run a new SaTScan analysis to prospectively detect a reportable communicable disease outbreak. To follow along interactively, download the corresponding sample analysis files at SaTScan.org. After you watch this video, you should be able to interact with the SaTScan software graphical user interface, generate required SaTScan input files for an analysis, and understand our recommended SaTScan parameter settings. These recommended settings are as of SaTScan version 10.3.3 released in September of 2025. These recommendations are summarized in Table 1 of our tutorial published in the Journal of Medical Internet Research, Public Health and Surveillance, along with other recommendations for advanced options and fine-tuning, which are covered in additional videos. Before you run an analysis, you need to create input files outside of SaTScan, including a case file that contains temporal and spatial information for all cases in the study period. We automatically create a case file each day using SAS code and export to a date-stamped folder to avoid overwriting case files from previous days. This sample analysis is for illustrative purposes only and reveals no confidential patient information. The case file, which is usually a comma-separated or tab-delimited file, must contain a location ID, which in this example is a census tract number. Its corresponding spatial coordinates are specified in another input file, the coordinates file, that we'll describe later on. The case file must also contain a temporal element such as a diagnosis or symptom onset date. The sample case input file provided is formatted as having one row per event, like on the left. You also have the option of creating a case file aggregated by location and date, with a column that indicates the number of events at that location on that date, like on the right. But we recommend using Format 1 when you can, because you can't include case-level descriptive variables in Format 2. These variables aren't used in the analysis, but can be helpful to include in output files to aid in cluster investigation. To create a new SaTScan analysis, open SaTScan and choose to create a new session. To open an existing parameter file, open a saved session in the Start window or in the File drop-down menu. To import your case input file, click on the button next to the case file box to open the Import File wizard. And point to the case file here saved on your computer. You can indicate if the first row of the case file contains column names and how the columns are separated in the file, for example, by commas. In this example, we're using the space-time permutation probability model, which is specified in the first field of the window, and requires the location ID, event date, and number of cases. In the box below, click on Unassigned in the source file variable column to specify which variables in the case file correspond to the required SaTScan variables. Clicking Next brings you to an optional window, which is described in the Advanced SaTScan Input and Output Features video, and we can skip that one for now. Finally, choose to save these settings to read directly from the file source while running the analysis. Back on the main input screen, if the case file is at the daily resolution, set the time precision to day. Next, set the study period start and end dates. It's important to balance the need for a study period that's long enough to establish a stable local baseline for each spatial unit, yet short enough to avoid variable secular trends like differences in the growth or decline of the underlying population across census tracts. As a rule of thumb, the study period should preferably be at least 3 times as long as the maximum temporal cluster size. For most diseases, a study period of 1 year is reasonable. For prospective analyses, the study end date should be set to the previous day or the most recent day with sufficiently complete data. Every spatial and spacetime analysis must use a coordinates file, which can also be loaded using the File Import wizard. It must have exactly one row per location with a location ID and the geographic coordinates of its centroid in either latitude, longitude, or Cartesian XY. The location IDs should match the ones in the case file, and if a census tract is missing from the coordinates file, cases in that census tract will be omitted from the analysis. To use the built-in SaTScan map features, coordinates must be in latitude and longitude. Next, navigate to the Analysis tab. To prospectively detect acute, ongoing, and localized disease clusters, request a prospective spacetime analysis using a spacetime permutation model, and scan for areas with high rates. While the Poisson and Bernoulli models may also be used for count data, we recommend using the spacetime permutation model in most instances because it only requires case data and it automatically adjusts for purely spatial variation, like areas with more or less access to care and testing, and for purely temporal patterns, like seasonal increases or decreases. Next, open the Advanced Analysis Features window. We'll move through the different tabs in this window to specify more parameter settings. On the Spatial Window tab, we recommend allowing the clusters to expand in size to include up to 50% of all events during the study period, because this imposes the fewest assumptions. This is reasonable for modestly sized areas such as New York City, but it might yield too large and uninformative clusters in larger jurisdictions. If an analysis consistently produces results that are unsatisfactory like this, or for another reason, for example, signaling too often or missing outbreaks, please see the System Fine-Tuning section in Multimedia Appendix 1 of our published tutorial for suggested solutions. On the Temporal Window tab, we recommend scanning for clusters that are up to 30 days long for most diseases, which is typically enough to encompass the upslope of an epidemic curve for point source outbreaks. We typically set the minimum temporal cluster size to 2 days because few true outbreaks of the diseases we monitor span only 1 day, and not evaluating clusters of only 1 day duration slightly improves power, given less statistical adjustment for multiple comparisons. We require a cluster to contain 2 events at minimum because we want to quickly detect outbreaks before many events accrue. The spacetime permutation model automatically adjusts for purely spatial variations and for purely temporal patterns, including day-of-week effects, so no further temporal or spatial adjustment is necessary. If you review your data and determine that the day-of-week pattern of diagnoses varies geographically, such as due to geographic differences in healthcare-seeking behavior, then you have the option here to adjust for day-of-week by space interaction. We generally don't find it necessary to apply this option. On the Inference tab, we typically use 999 Monte Carlo replications with the default p-value option to end early if the p-value is large. You can now close the Advanced Features window and move on to the Output tab. On the Output tab, specify the name and location where the results file will be saved. The results files include the main results text file and any other requested files such as maps and line lists. Next, open the Advanced Output Features window for more output options. On the Spatial Output tab, choose the criteria for reporting secondary clusters. Any disease might have multiple active outbreaks at any moment, so secondary clusters should be reported by enabling the most likely clusters hierarchically option and choosing the no cluster centers and other clusters rather than the default no geographical overlap. This allows reports of slightly overlapping clusters so that clusters located close to each other can be detected and can also help to define the extent of irregularly shaped outbreaks. At the same time, it avoids redundant clusters that are almost identical to each other, as well as clusters almost completely driven by the primary cluster, but with large outlying areas with no or modest excess risk. When the parameter settings are finalized, save the session as a parameter settings file and click the green arrow to run the analysis. A process window will appear while the analysis is running. and a results window is shown when the analysis is finished. We cover how to interpret SaTScan output, including this text-based results file, in the output interpretation video tutorial. When setting up a new SaTScan analysis, we recommend creating and maintaining a summary of analysis parameters similar to Table 1 and the appendix table excerpted here from a 2021 publication describing an analysis adapted to detect clusters of COVID-19. It's important to document decisions made about specifications and settings, especially to have a record of modifications over time. The recommendations we've covered in this video are derived from underlying public health and statistical principles that should be generalizable to other jurisdictions. Please refer to our published tutorial for more details about this analysis and to Multimedia Appendix 1 for recommended settings for other analyses.